What's up, math scholars? Mrs. Harp here. Welcome to day 1 of air test practice. So who's excited about air test? Woo! They've already taken the English, right? Biology's next week, then math, and then, is that it for freshmen?
Yeah.
Well, that's good. That's good. So you're 1/3 of the way there. So this homework was assigned last night, and I'm not going to come around and check it because it's just 4 multiple choice questions. We just want to discuss it real quick. For 1 ticket, did anybody get an answer for number 1? And you have to explain why you got your answer. Can you do that?
Yeah.
All right, Arjun, what did you pick and why?
I got C.
Okay.
Well, because A, it doesn't talk anything about a price in the paragraph above. The months is already 6x, so it could be B. And it doesn't say anything about the title subscription she gets. That's why I got C.
Okay, I mean, C is correct. It's definitely going to be 40 in the box to begin with and getting 6 more per month. This is actually slope-intercept form. Remember slope-intercept form? Where like 6 is your slope and 40 is your intercept. So that's like your starting amount and that's your slope. Right? They just have it reversed. Y equals mx plus b. It's an important equation. All right, number 2. How many of you thought to use Desmos to graph this last night? No one. Well, I'm here to tell you, you can use Desmos to graph this. So let's open up our Desmos. Every single problem that you can use Desmos on today, we will try it, all right? So let's graph it. X squared. Now, first of all, see this f of x? You have to type that in as a y, but you guys are getting pretty good at knowing that. So you're in your Desmos. You're typing a y instead of an f of x. But then x squared was a plus 2x minus 1. Am I remembering right? And you know me, I love the hover click to find these key points. So there's your 2x intercept, there's your y intercept at -1, and there's your vertex down there at -1, -2. Looks like people are typing in the Chromebook, so we'll give them a second. So now that you see it, for 1 ticket, raise your hand and tell me which one I want to circle. Jalen? Which one? Maybe. Let me look at it again. I seem to have forgotten. Where's my little boxes are in the way? I do not think it's B. This is B down here.
Oh, sorry, I didn't see
C, yeah, definitely. All right, so making sure. So it does have the correct vertex. It does have the correct y-intercept. Those are 2 key points I used to identify our choice. I'll just keep the ticket since he said B. It's okay. So we're okay on number 2? All right, 3. Oh, this is a good one. This is kind of what we just finished. It's almost like using elimination type methods. But they want to know which system of any linear equations would have the same solution as the system above. And it's awkward because there's no K and there's no L. But you can still figure out an answer. Anybody want to give their answer they got last night a whirl? Nobody wants to give it a try? So it's actually B, and here's why. The bottom equation, if you look at it really closely, remains unchanged. The top equation, what they did is they went through and multiplied everything through by a -2, and so they got a +6, a -2y, and a -2k. So really it is the same exact system of equations as up there. The top has just been multiplied through by a constant. And then 4. Would somebody like to give their answer a try? Jaden? Good. How did you get that?
I used the quadratic.
Quadratic formula definitely would work. So she probably added her 11 over 4 over to the side. And then she assigned A, B, and C values and used the quadratic formula. Do you want to know something? Desmos could have got this answer for you. This is a parabola, and if we graph the parabola, the 2 x-intercepts will be our solution points. Let's show you how to do that. So Desmos is an option on every single problem on the air test. So if you can use it, you want to use it. So can you tell me the equations since I forget? X squared
plus 6x equals -11 over 4.
Bam. So this is a parabola. It goes up really, really, really high. In fact, I think earlier we scrolled out to like 1,500. It was still going. See, it's still going all the way up to like, who even knows? I'm at like 10,000 still going. So that doesn't matter. what matters is these x-intercepts. You hover click, x-intercepts for parabolas are the same thing as solutions for parabolas. So these are the same answers that Jaden got when she did her quadratic formula. Okay, pretty cool. All right, so now we are gonna go to the packet. So the packet is just gonna go through topic by topic. It doesn't have a lot of writing space, so I would have like a notebook paper beside it to do some of the sample problems that we'll be doing. So for example, like the first topic is the order of operations, and I'll have an example problem, but there's not much space on the packet for you to do it. Make sense? All right, so for one ticket, can you remember the acronym we use? So the saying that would give me the PEMDAS. Jess? Please excuse my dear Aunt Sally. Perfect, here's your ticket. Just keep in mind, multiplication and division and addition and subtraction happen at the same exact time from left to right. So go ahead and try this one all by yourself. We'll see what you get. All right. Did you start with the parentheses? The 2 plus 8. So 2 plus 8 is 10. What did you guys do next? Exponents, perfect. 6 squares, 36. So I'll just put a 36 right here. What did you guys do next? Yep, division would come next. 10 divided by 5 is 2. And then we can add and subtract from left to right at the same exact time. So 5 plus 36 is 41, minus 2 is 39. Sound about right? All right, easy enough. Let's move along to the second topic. Exponent rules. So we definitely did these this year. We had a rule that if the bases were separate, that you would add the powers. We had the rule that if they're top and bottom, you could take the bigger exponent and subtract off the smaller. I had a song, remember that? Bigger minus smaller, put the answer where the bigger lived. Is that ringing a bell? All right, maybe one smile, a couple grimaces. And then these two, they're separated with the parenthesis. Those would multiply. All right? So for one ticket, tell me what this answer would be. Carly? X to the 19th. Perfect. All right, for one ticket, let's do this next one. Bigger minus smaller, put your answer where the bigger lived. Jaden? Perfect. So she did 12 minus 3, or sorry, 15 minus 3 got 12, and that has to go in the numerator. That's where the biggest exponent has been. How about the one on the far right? Louise? Perfect. So she multiplied those two. I have one more sample problem that deals with exponents right here. So give that one a try, and I'll get a volunteer to give you an answer. All right, who's got it? Alexa? So close. I love the m to the 10 idea. The problem is that 4 is a normal number, so you don't want to treat it like an exponent. You don't want to do 5 times 4. You actually want to do 4 to the 5th. Does everybody remember where your exponent button is on your particular calculator you're using? Try type it in 4 to the 5th, because it's kind of a large number. 1024. So if you can't find your button, have a neighbor help you find it real quick. Everybody's button is a little bit different. Mine's a caret. But some people, the button kind of looks like this. Depends on your calculator. Foiling. First, outer, inner, last. So when we did this, some people like drawing the rainbows. Remember that? First, outside, inside, last. And some people like drawing a 2x2 box and having everything kind of distribute that way. So go ahead and try this problem using whatever method that you want. Okay? And pause. When you're ready to check, you can look up. I'll do it real quick. Different. We're doing adding and multiplying. These will have two totally different answers. Let's see how you guys can do with it. Can I have a volunteer tell me what they think this first one would be equal to when we add? Adding like terms is how I would say this. Luis? I love your x to the third idea. It's not going to be a 16 though. We're adding. So we've got 4x to the thirds, and we get 4 more x to the thirds. How many x to the thirds do we have? Perfect. 8x to the third. So yeah, you do just keep it x to the third when you add like terms. All right, what about down at the bottom? 4x to the third times 4x to the third. What do you think is going to happen with this one? No guesses? So the 4 and the 4 multiply, so that's we are going to get a 16. But the x to the third and the x to the third are just being multiplied. And when you use your exponent rules, those powers get added. So 16 x to the 6. We did a whole bunch of factoring methods when we did factoring. We did grouping that you would do when you had 4 terms to start with. We did old-fashioned method, and the old-fashioned method is when you had like no number out front, but you did have 3 terms, something like that. Actually, that one is not even factorable. Let me make that a 9, and then it would be factorable. We had box method when you had a number out front, like maybe a 5x squared. And then I think that's all the 4 methods. Oh wait, common monomial. Common monomial is not so much a method, but just making sure you don't have anybody in common in all your terms before you start. So I have a whole bunch of examples here. I think I have 4 examples we're going to go down through. So the first one here, do you remember what method we would have used? There's no number out front. There's no common monomial in my 3 terms. I always call this the old-fashioned factoring technique. So you just simply brainstorm numbers that multiply to 16 that would add up to 10. Anybody think they know those numbers for a ticket? Sandy?
8.
Awesome. Yep. So we write that x plus 8 and x plus 2. And if you want to check, you could FOIL it out. It should FOIL out to what you started with. Sure. Right, the second one, the minute I looked at it, I saw the 2 and the 30 and the 72, and I was like, oh, that 2 out front will make this a box method. But 2 and 30 and 72 all have a common monomial of 2 that we can pull out front. So let's work on pulling the 2 out front. For one ticket, after I pull the 2 out front, what will be left on the inside? Jalen? Good. Perfect. And now we kind of lucked out. Once the 2 was out of our way, this was the old-fashioned method. So we're going to do some brainstorming again. What numbers add to negative 15 that multiply to 36? If you know, you can have a ticket. Let me know. Jaden? Negative 12, negative 3. Perfect. Good job. And I always say, beware of the double negative. These ones are tricky because they multiply to a negative but add to a positive. Or if I said that backwards. Multiply to a positive, add to a negative. There we go. Well, that one's done. This next one's my favorite method, grouping. We have 4 terms, and we would always do this with colors. We have a pink group, and we have a green group. So we're going to do common monomial factoring out of our pink group. What do our 2 pink guys have in common? Yeah?
2x.
A 2x, perfect. So let's pull this 2x out. That would leave me with 4 plus 5y. Now you want to kind of think this through. You want to pull something out of the green group so you can be left with a 4 plus 5y in parentheses. We kind of thought ahead a little bit when we would do these problems. Do you know what we could pull out front to be left with a 4 plus 5? Yeah? A 3, perfect. All right, I think this is why I love this method so much. I got to do some magic. Abracadabra. So abracadabra, 2x and 3 make a new group. And abracadabra, 4 plus 5y make their own group. So there's box method. Pretty fun. Oh, I'm sorry, grouping methods. That was grouping method. My bad. The next one's box method. This is our last factoring problem. So there's that 2 out front. That's what's causing this to be box method. And there's no common monomial of 2, so it's not like I can remove it. This is probably the hardest method to remember how it works. The 2x squared goes in your upper left box, and your 3 goes in your lower right box. Does this ring a bell at all? Arjun has already drawn a circle, so he remembers. What are we going to do next?
6 over there.
Perfect. So 2 times 3 is 6. I always cross that guy off and put my 6 and circled him. Now we think of numbers that add up to 5 and multiply to 6. And they're going to fill our remaining 2 boxes. No! No! No. You're having a brain fart.
Negatives.
No, they're all positives. All right, let me take you through my brainstorm list. 1 and 6, or 2 and 3. Those are the numbers that will multiply to give me 6. Now, which ones add up to 5? Yeah, you got it. It happens to all of us. You're good. All right, so 2 goes here, and 3 goes here, and they both got an X. All right, we're going to pull out the top row what they have in common. So a 2 and an X. And then on the bottom row, a 3. And now I'm kind of working around my Punnett square backwards. I love that a lot of you are in biology. 2x and x is 2x squared, and 2x and 1 is 2x. So what you see in blue is kind of our final. X plus 1 and 2x plus 3. Alright, I'm not going to take you through singing the song quite yet. We will sing it in a moment. But the quadratic formula you use to solve something that cannot be factored. Now, if I truly had to solve this, I would probably go to Desmos and solve. But you never know when they would want you to demonstrate some knowledge of the quadratic formula. So let's go ahead and just try the quadratic formula. We have to be set equal to 0 before we can sing our song and do our A, B, and C. So we're going to move our 10 over. You've got 3x squared, positive 8x, and positive 1. And then we're ready to identify that A is 3, B is 8, and C is 1. All right, you guys brought your singing voice to class today? Oh, does Hannah like singing? All right, and a 1, and a 2. X equals the opposite of B, plus or minus the square root of B squared minus 4AC, all divided by 2 times A. And back when we did this, I would say grab your calculators, but don't type it all in at one time, because that would be terrible. You only want to type in this stuff at one time. So I would type in 8 squared minus 4 times 3 times 1. Of course, I messed up and I put a multiply sign where I wanted a minus sign. That gave me 52. I normally do my 2 times 3 in my head, so that's 6. That's easy. All right, we can go ahead and square root the 52. That guy was called our discriminant. That gave me the 7.21. So at this point, I'm going to do the math problem twice. I'm going to do negative 8 plus 7.21. Click Enter, divide by 6. That's your first answer. I'll just put it over here where I have some space. So my first answer is negative 1.3. Sorry, I said that wrong. Negative 0.13. Okay, that's better. And then the second answer is negative 8 minus 7.21. Divide by 6. Negative 2.54. Okay. Ooh, are we down to the practice problems yet? Yay, we're at the practice problems. So let's try this next one. It's about gravity. So this one's a little tricky because there's just so many variables, but it doesn't end up being as hard as you might think. G is the gravitational constant, M1 and M2 are masses of the two objects, and R is the distance between two objects. I almost feel like we're in science class here with this big old formula. Which equation correctly shows the distance between two objects? So we basically want to solve for R. So we have this formula, F equals G times M1 times M2 over R squared. We want to solve it for R. So first things first, is R in a nice location down there in that denominator? No, we do not like variables in our denominators. So we're going to multiply both sides by R squared. That'll kind of get R out of the denominator. How is gone? Goodbye. Alright, so we're solving this for R. The F needs to go next. So how do we think we can move the F? Subtract it over or divide it over? You know? Divide, yeah, because they're multiplying, so very good. So divide both sides by F, and then the F will be gone. So goodbye, F. And now we're solving for R. So how do we get the squared to go away? Good. Square root both sides. So then that squared will be gone, and we will have been solved for R. So, there are two choices that look really, really, really similar, B and D. Do you see the difference between B and D? Do you know which one we should choose? So the difference between B and D is one has the F as part of the radical and one does not. So we want the one with F, E being in the radical, so it's D. Okay, the next one I want you to try by yourself for your homework, so we'll skip that real quick because it's pretty easy. So this is your homework problem. Just put a star and say finish that tonight. We'll go over it tomorrow. This one, same deal. Try this one tonight by yourself because it's pretty easy. Now let's do this one together. This one is a calculator problem, but you definitely need to know where some buttons are located on the calculator. To do 16 to the 5/2, if you're using a calculator like mine, you literally can just do the caret and then the 5/2 are all up there. But if you're using a TI 30 or 34, you need to do the caret and then parentheses. So everybody's calculator is just a little bit different. Try how you think it would go into your calculator and see if you get the answer I get. It's 1024. If you can't get 1024, let me or a neighbor know. We'll help you with the calculator. All right, so basically we're going to check mark every single entry over here that is equal to 1024. So 4 to the 5th? Yes, check mark. 8 to the 5th? No, it's 32,000. The square root of 16 to the 5th? Yeah, that's 1024. Now, have you ever done a 5th root? I did not think so. To do that one, you have to do 5 and then a button that looks like this. So on like the calculator that Arjun has, that a lot of you have, you will hit 5 second caret to get to that funny button. And then you can just do 16 squared. You might need parentheses around the 16 squared. Yeah, you're going to need parentheses. Now, doesn't Carly have one like me? So you're going to hit 5 first to do the 5th root, and then the math button. And it's the 5th choice. So you can either go down and select or just hit number 5. And then at that point, you can just do 16 squared. So the 5th root of 16 squared is 3.03. So it's not that one. Let's try this one. 16 squared times 16 to the 1/2. That's 1024. And then the last one, 16 to the 5th times 16 to the 1/2. It's like 4 million, so that's not going to be checked. So if you had trouble with any of these, I can pause and help you with your button. All right, hello everyone. I don't remember when I paused the video, but we basically had some data points, and I wanted to refresh with the students how Desmos can fit a line to the data points. So we went in, inserted a table, and then for our equation, did y1 tilde m times x1 plus b. This R value will tell you how good of a fit it is. A 0.895 fit would be like an 89.5% fit. So it's an okay fit. I'd like to see a 99% fit. That's because our data is not the best. But I could write the equation out. Y equals, and they're going to give you the slope and the intercept. Y equals 18.7x minus 16. They give you the slope and the intercept right there on the computer. Cool. All right, so let's head back over here. We are just going to bypass the slope-intercept form stuff because we did it recently, and we'll just do some practice problems. We have two graphs here, f and g. Did you find this one from the next page? Where g of x equals f of x plus h. G of x equals f of x plus h. They want to know what the value of h is. So in other words, like how far has one graph been slid up? That's how I thought about it. How far has it been slid up? Just count it. 1, 2, 3, 4, 5. It's been slid up 5, so h is 5. All right. This, I think I just scroll down to find the next one. Scroll down. Hello, this is the marbles in the empty bucket. Try the marbles in the empty bucket all by yourself tonight. We'll check it tomorrow. Try the Ryan problem by yourself tonight. We'll check it tomorrow. So just star these ones. Let's do this one together. So I looked at this one and I was like, oh great, it's going up by 25, it's going up by 25. Yes, this would make a straight line. But then I looked at it closer. Do you see this column? It's going from 0 to 2 to 3. So they're skipping a whole data point. So if I would put this in the chart, it's going from 0 to 1 to 2 to 3, and they're skipping a whole data point. So it's not actually going to make a straight line. Does that make sense? So you don't want to choose A or B because that's saying it is making a straight line. Linear means makes a straight line. We would want to choose it's not linear. So it's one of these. Let's just read the difference. It's not linear because f of x does not increase by a constant amount compared to x. Or it is not linear because f of x does not increase by a constant percentage. That doesn't even make sense. Percentages are multiplying. So we're going to go see. All right, I do want to do the next one with you. Do you remember about domains? We want to pick a function whose domain, that's x values. We want to pick a function whose x values are the set of non-negative real numbers. So we basically want all of our x values to be positive. Are all of these x values going to be positive in this graph? Probably not, because if I lived here, I would have a negative x value. So it's not A. These x values are all positive. Positive, positive, positive. But let's check the other ones. These x values are all negative, so definitely not D. And when I looked at this one, I was like, hot dog, all these x values are positive. So I had to select between C and B. I'm going to tell you why it is not B right here. It is not B. Not because of the domain. The domain is awesome. The domain is definitely a set of positives, non-negatives. It's because it's not a function. If you would draw your function test, see how it would touch twice? It touched twice. This one fails the function test, the vertical line test. And if it fails the vertical line test, it's not actually a function. We have to go and see. This is a very tricky, one of the most trickiest error questions I've ever seen. It's on last year's test. You could probably try the sunflower one on your own tonight. We'll do this one. Looks like they made a scatter plot. They have a correlation coefficient of negative 0.938. So it's like almost like a 94% fit. So it's a really, really good fit. Can't quite see all my graphs right now. But the negative out front, I don't know if I've ever talked to you about that. The negative out front means it has a negative slope to this line. So we want data that's making a negative slope that would have a really, really good fitting line. Let's look at all four choices. So this would have a positive line, and we would not want to pick that. This would probably have a positive line. I would not want to pick that. So we're between this one, which is, this data is just all over the place, or this one. And this one here would have a great fit, and it would be negative. Go with A. That makes sense. And then we'll finish this last one together. Let me grab mine so I can read it closer to you. All right, it says that Rhea is solving an equation below and giving reasons for doing each step. And this will be fun. And it's kind of like multiple choice because the reasons are below. So this is kind of like the given problem. If I was solving this problem, I would probably distribute this 2.5 first. Would you agree? Let's go ahead and grab our calculators and do that. So 2.5 times 6.25 would be 15.625 x. And then 2.5 times 0.5 is 1.25. And then that would equal 11. We don't need to distribute to the 11. And I use the distributive property. So that reason would go here. Now if I'm continuing on my solving journey, I'd probably subtract my 1.25 over next. And that would give me 15.625x equals 9.75. And it makes sense that she used the subtraction property of equality there. But then how would I get from step 3 to step 4? What would I do? Divide both sides by that 15.625. So I think the reason would definitely be the division property, because she's using division for her last step. Does that make sense? All right, so we're going to be done. I just want to look at Arjun's paper to tell you officially how many homework problems you have. So you have the Trent sunflower problem, that's 1. You have the Ryan problem, 2. The Henry problem, 3. The distribute problem, 4. And the solve problem, 5. So you have 5. That's not bad. 5 multiple choice. Most of them are multiple choice. Some are not, I guess. Error question homework. Chris, any questions? All right, well, thanks for watching the video. It was kind of a long one. I don't know if anybody watched this, but if you did watch the whole way, A+.